Hello class, welcome to this video on the Spring Break Challenge Part 2 as we are gearing for EOC review. So let's look at number 6. It says look at the two parallelograms KLMN and WXYZ. Select all the transformations that prove the parallelograms are congruent. All right, so we got reflection, then we got translation. All right, so remember reflection across the x-axis. The rule is, so you got reflection, x-axis, that's xy maps to x negative y. And let's look at all these transformations. So we got x-axis, we got translations, looks like we got y-axis reflection, and that's it for the transformation. So let's do the y-axis, and that's xy maps to negative xy. All right, so we got those rules. It says we're going from here to there. So this is the pre-image. Oh, actually, it's not saying that. Let me see. Reflecting parallelogram. Okay, yeah. So it says you're doing transformations on this. Okay. So this is going to be the pre-image, and this is going to be the image. All right. So focusing on KLMN. Let's pick one point. So let's pick point L, which is 6, negative 2. And let's transform it. So it says reflecting the parallelogram across the x-axis. So that means you're going to have 6, then a double negative for the y-coordinate, which is going to make it positive. And then you're translating it 10 units to the left. So we're going to say 10 to the left. So that's negative 10, 0. Remember that this is your translation vector. Right, so this is saying you're moving it 10 to the left. So that means it's 6 minus 10. So we're going to do 6 minus 10 here. And that's going to be negative 4, 2. Now, is that the coordinate for, we're going from L to X, right? So from L to X. So the coordinates of X are, let me just write it here just so I have it. It's negative 4 and 2. Well, that's the coordinate that we have there, right? So that checks out. So this checks out. Now let's do the next one. It says translating it 10 units left and then reflecting it. Okay, so 10 units left and then reflecting it. So we're going to do the translation vector. So we got to do minus 10 to that. So then that's going to be negative 4, negative 2. Then if you reflect it across the x-axis, it's going to have the double negative effect, which makes it positive. So yes, that works out. All right. And then it says 10 units left and 6 up. Okay, so let's do that. So 10 units to the left and 6 up. So that's a positive 6. All right, so minus 10 here, but plus 6 there. All right. So 6 minus 10, negative 4, negative 2 plus 6 is 4. All right, so it's not that one, right? Although it was close. Translating or reflecting it across the y-axis and then translating it 6 up. Okay, so let's do that. So this is the y-axis, so it's going to be negative 6, negative 2. And then we got to go 6 up. So that means 0 in the x direction and 6, positive 6 in the y direction. So we got to add 6 to this, which turns into negative 6, negative 4, which is definitely not that. All right, and then let's do the next one. It says 6 up and 10 left. 6 up. So positive 6 and then negative 10. Or no, actually 6 up, 10 left. So negative 10 and then positive 6. Let's see here. Actually, yeah, that's the same thing as that. And we said that wasn't it, right? I wonder if that's a typo or not. And it should say 6 left and 10 up. Okay, so just in case, I'm going to do that. 6 left and 10 up, because we just did that here. We said that didn't work. So we got 0 and then 8. So definitely not. And then 6 up and then reflecting across the y-axis. So let's do that here just because I'm out of room. 6 up, so 0 and then positive 6. All right, so we got to do this plus 6. This is 6 comma 4, and then reflecting it across the y-axis is going to be negative 6, 4. So definitely not. So it looks like we only have those two solutions. All right, so number 7. 4 points are shown on the number line. Points A, B, C, and D have weights given here. So those are the weights for A, B, C, and D. Choose the correct option, the weighted average. Okay, so let's do the weighted average. The formula for the weighted average, I'm going to say WA, okay? So for weighted average is X is equal to, you take the weight, W1, times the X coordinate for the first point, plus the weight 2 times the X coordinate for the second one, plus the weight 3 times the X coordinate of the next one, plus W4, X4, and you keep doing this until you get all the X coordinates. We have here 4 points, so there's 4 X's. And then divide by the different weights, add the different weights on the bottom, okay? That's your formula, and again, repeat, continue until you do all the X's. But here we have 4 X's, 4 coordinates. Now this is X1, which is equal to 3. This is X2, which is 6. This is X3, or 7. This is X4, which is equal to 9. So we got the X coordinates and we got the weights. This is the, let me just do this. Let's call this W1, W2, W3, and W4 here. All we got to do is just plug it in, right? So we got X equals 0.5 times X1, 3. W2 is 0.2 times X2 is 6. Plus W3 is 0.1 times X3 is 7, plus W4 is 0.2 times X4 is 9. Divide that by 0.5. I'll add up all the weights. But if I add up these weights on the bottom, I get 0.4, 0.5. This is just equal to 1. Okay? So it doesn't really do anything. So all we got to do is just focus on the numerator, because anything divided by 1 is just the same number. All right, so 0.5 times 3 is 1.5. 0.2 times 6 is 1.2, plus 0.7 plus 1.8. And we just got to add these together. So we get 2.7, 3.4, and then 5.2. Looks like it's 5.2. All right, and it lies between the points, so 5.2 is right here then, right? So it lies between A and B. Looks like it lies between A and B. All right, so the weights of points A, B, C, and D are changed. Now we changed them. Choose the correct option. The new weighted average lies between, okay, so we just got to calculate the weighted average again, but this time with points 2, 0.2, and 0.4. So let's just recalculate it. So we got points 2. The X coordinates are the same, but the weights change. Times 6 plus points 2 times 7 plus 0.4 times 9. And then add the weights, 0.2 plus 0.2 plus 0.2 plus 0.4. All right, 0.4. So this is equal to 1 again, so we can just ignore that and just do the math here. So we get 0.2 times 3 is 0.6. We have 0.2 times 6 is 1.2. We got 1.4, and then we got 0.4. I want to make sure I got that. Yes, 3.6. Okay, so double checking that. And then add them up. So we got this is equal to 5, and this is equal to 1.8. So it looks like it's 6.8. All right, so it's 6.8. And now, if it's 6.8, then it's here, and it lies between B and C. All right, so let's look at the next one, number 8. Rectangle KLMN has the following vertices, and it says match each description with the correct number. All right, so we have a rectangle with the given coordinates, and we just have to find the perimeter and the area. Okay, so we just want perimeter and area. All right, so K, I'm just going to do a quick graph. So K, 1, 2, 3, 4, 5. 1, 2, 4, 5, 6, 7. That's -6, -5. And 1, 2, 3, that's 4. Okay, so then we got 1 here. So 1, 4, that's L. We got 0, 7, that's M. We got -6 and 5. That's n, and then we got 1. Yeah, we just did that one. -5 and 2. And that's k. All right, so there's our rectangle. So we got to find the perimeter and the area. Let's do the area first, actually. So to find the area, we need to we need to find the distances for all these sides. Okay, so we need to count them down and over, up and over, all that stuff. So this one, it looks like it goes down 1, 2, 3. It looks like it goes down 3, and then over 1. And this should be the same thing here. It says it should go over 1 and then down 3. And then this one goes up, looks like 2, and over 1, 2, 3, 4, 5, 6. So it looks like it goes over 6. Okay, and so this should be the same thing here. Over 6 and then up 2. All right, so let's find the distance. Let's find the length for kn. Okay, so to find the length for kn, you just take these two numbers, square them. So we got 3 squared plus 1 squared, right? These two numbers, that one, and then this one right here. That's for kn. Well, that should be the same thing as ml, right? So I'm going to put here ml is also equal to that. All right, and then we can do the math there in a second. Now let's do lk. So lk, which is the same thing as mn, is 6 squared and 2 squared, right? Because those are the two sides. So 6 squared plus 2 squared. All right, so now we can do the math here. So we get square root. 3 times 3 is 9. So you get 9 plus 1. And you got 6 times 6 is 36. And then 2 times 2 is 4. So we got square root of 10. And then square root of 40. All right, so there you go. So now let's do the area. So the area, remember the area of a rectangle is base times height. Okay, so we have to multiply the base. This is the base, and then this is the height, right? So we got to multiply basically these two. All right, so square root of 40 times square root of 10. Well, then I can just multiply those together. That's going to be square root of 400. And the square root of, because 40 times 10, and then square root of 400 is 20. Okay, so we got our area. So let me just box that. So here we got area is 20. All right, now let's do the perimeter. So the perimeter is when you add up all the sides, right? So that's what we're going to do. We're going to add up these 4 sides, but we already know what they are. So let's just add them up. So we get, and actually, let's break these apart. We can break apart the square root of 40. Remember when we broke down radicals? So let's break that apart. We can break this into 4 times 10, and 4 is 2 times 2, and then 10 is 2 times 5. Notice we got a pair of 2s that we can give the boot, so that can get kicked out, okay? So then this turns into 2 times the square root, and then the rest of them have to be multiplied back in. So it's going to be 2 square root of 10. All right, so that's what square root of 40 is. So let me just write that, 2 square root of 10. All right, so now we got square root of 10 plus another square root of 10, because remember you have 2 sides. So let me just draw the rectangle. So you got square root of 10 here, you got square root of 10 there. This is 2 square root of 10, this is 2 square root of 10 on the picture. And we just got to add them all up. All right, remember this is an invisible 1 here. So it's really 1 square root of 10, 1 square root of 10. So we got 1 plus 1 square root of 10 plus 2 square root of 10 plus 2 square root of 10. That's a total of 6 square roots of 10. Okay, because 2 plus 2 plus 1 plus 1. All right, so there is your perimeter. All right, and they have that as an answer. Okay, so that's your perimeter and area. All right, so let's look at last couple examples. A human head can be approximated as a sphere with a circumference of 60 centimeters. What is the approximate volume of a human head rounded to the nearest 1,000 cubic centimeters? So to the nearest 1,000. Okay. All right, so we got a sphere, right? We're just going to approximate that. And it says it has a circumference of, so this is the sphere, but it has a circumference of 60 centimeters. So in your formula sheet, we know that the volume of a sphere is 4/3 pi r cubed. So that should be in your formula sheet. That's the volume of the sphere. So we need to figure out what the radius of the sphere is, okay? So that's what we got to find out. So let's do that. We got it, and we can do that by using the formula for circumference, which is also in your formula sheet. So circumference is 2 pi times r. But we also know that circumference is 60. So let's plug that into there. We get 60 is equal to 2 pi r, and then we can divide by 2 pi on both sides to get rid of the 2 pi and solve for r. So now we know r is 60 divided by 2 pi. Okay, I'm not going to round that just yet because I'm going to plug that into the volume and then I will round it. Okay, so I'm just going to leave that for there and plug that into this formula. All right, so we get 4/3 pi times, now we got 60 divided by 2 pi raised to the 3rd power. All right, and then we can, of course, calculate this and get an answer. All right, so using Desmos, we could do that as well. Okay, here we go. We got Desmos. So we got 4 divided by 3, and then let's use the arrow. We got pi, and we got in parentheses, we can do 60 divided by 2 pi. Notice it's in the bottom, and then close the parentheses, and then raise that. This is the power for the exponent. Raise that to the 3rd power. All right, so there you go. So we got 3,647.56. All right, so I'm going to put that 3,647.56, and then we want to round it to the nearest thousand, right? Okay, so we want to round it to the nearest 1,000. So now this is the 1,000 place. So now we notice that this number right here is 5 or bigger. So that means we're going to bump this number up, okay? So we're going to round this to about 4,000, all right? So 4,000 centimeters cubed, okay? Make sure you know how to round things like that. So you're not going to put the answer as this. You're going to put the answer as 4,000. All right, so now it says number 10, the diameter of the base of a right circular cylinder is 28 centimeters. Okay, so we got a cylinder. And they said that the diameter is 28 centimeters. And its height is 21 centimeters. What is the total surface area of the cylinder? Okay, so the surface area formula. All right, so now if you go to your formula sheet, it would say for a prism or cylinder, the surface area is 2b plus ph. Okay, and they use lowercase h, but I usually change that to capital H when I write it down. Okay, so now remember, B is the area of the base. This is the base. Okay, now we know that the base is a circle. So now we need to say, okay, what is the area of a circle? So then on your formula sheet, it says that the area of a circle is pi r squared. Okay, so this A you see here stands for area. We're going to replace that with B. Okay, so I'm going to replace that with B because that's what they use in this formula here. Okay, so now B, or the area of the circle, is pi r squared. I'm going to plug that in there. Okay, so we got 2 pi r squared plus, now the P stands for perimeter. And we know that when we're looking at circles, the perimeter is the same thing as the circumference, right? So we know that we're going to change P to C because C stands for circumference. What's the circumference of a circle? We just did that here, and that's in your formula sheet as well. Okay, so 2 pi r. Okay, so I'm going to replace the P with 2 pi r. So we got 2 pi r, and then of course we have the h. So this is your formula for the surface area of a cylinder. This is your more complete formula. So now we can use it. So now 2 pi. Now the diameter is 28, which means that the radius is half that, right? So 28 divided by 2 is 14. So let's plug that in here. 14 squared plus 2 pi times 14. Now we said the height was 21. All right, now they said to use 22/7 for pi, which it's one of those things. So let's just do what they said. So we got 22/7 times 14 squared plus 2 times 22 over 7 times 14 times 21. And we'll do this on the calculator, of course. We'll do it on Desmos. Okay, and if you do it on there, you should get 3,080. And it's going to be in centimeters squared. Okay, because surface area is always square units. Okay. All right, guys, that's going to do it for the video. Hope you found this useful and informative. And as usual, I'll see you in the next one.